Hi everyone, my name is Faso, and today I'm going to be talking about mental health, which is the issue I've been working on for this project and for the past semester. The question I've been working on is how can neuroscience be applied to help improve the diagnosis and treatment of mental illnesses? Okay, so when you read this question at first, you might think that wow, this is really really broad, and that's the way I have it set up because the question can be broken down to sub questions, I guess you could say, and that's how I have it set up so that I can kind of bring in more sources and organize sources in that manner. So the first sub question that I have is mental illness like other illnesses? Okay, and the reason I have this question in there is that before anything even begins, because before I talk about finding cures, it's really discouraging when you have something so complex like the human brain, which has more neurons than there's stars in the galaxy, of a newborn child. That's not even an adult. To try to pinpoint and try to find a cure in something that's that complex. But this source has one line that I think is really encouraging. It says, "Mental illness has a biological basis, just like any other illness." Okay, so no, it's not harder. I guess I mean it could be harder. I guess you could say, but it's no different than any other illness. If there's a beginning, there is also a cure for it. So I think that's the main thing I want to talk about is if we're gonna invest time, money into research of the brain or mental health, whatever else there might be, it's worth to know that there is gonna be a cure for it. Okay, so that brings me to if it is worth researching how prevalent is it, right, in today's society. Obviously mental health is a big thing. We get days off of school because for mental health day now, but the thing I want to talk about for as in terms of finding this source from Harvard was it talked about how it was a big thing back in the 90s as well. So we can see that in the 90s, it showed that almost half of American adults had some sort of psychiatric disorder. So mental health hasn't been a big thing for the past 10 years. It's been over 20, and that's just when we had surveys. Okay, so in the early 2000s, they did a survey, 9,000 out of 9,000 people, and around 46% showed some sort of psychiatric disorder, and that's an underestimate. Okay, so it shows that it's always been a big problem. It hasn't just started, and this is something that's worth looking into. So we have this chart right here. This chart basically shows actively people going out to seek help. So it's obviously been increasing as the knowledge of mental health has been going up. Okay, and so why is this so big? Why is it so prevalent? And by big, I mean why is this such a big issue? And the reason is we simply haven't had the technology in the past years to help develop better cures or diagnosis or treatments. Okay, so the main thing that I want to talk about for these sources is the invention of the fMRI, which is basically a functional MRI. So before the functional MRI, there was MRIs, okay? And the only thing that MRIs did was show the structure of the brain. With fMRIs, you can take an active brain that's thinking, you might be doing some sort of activity. You can see what the brain's actually doing, and it gives you a better indication of what that place is specialized to do. So with that, we've seen that someone with, depression has a different prefrontal cortex than someone who doesn't have depression. So there's been a lot of research advancements in terms of just because of this one machine. Okay, and so what does the future of mental illness look like right now? So this source, the reason I want to talk about this is obviously mental health is a huge thing. Depression is huge, uh, and you can see it's one of the leading causes of disabilities in the world. But the thing is, we need to look in terms of research at things other than just the brain, and this article talks about pathophysiological factors, so the factors that aren't necessarily in the brain but affect the brain in some way, shape, or form. If we don't find any connection to that, we might not be able to, you know, enhance our research on this topic. And so, why has advancements been so minimal? The reason is obviously technology, like I said in the previous slide, but the three things I want to talk about is crisis of diagnosis, explanation, and treatment. And the reason I want to talk about these three is that whenever we're doing research, those three things are a must. So the diagnosis crisis is basically we only diagnose things that are observable, and that's why we've been so set back. Is because a lot of mental health things aren't as observable. Explanation: we need to look for connections between other parts of the body. Okay, genes, for example, it's very hard to make connections, so we haven't been able to do that. And then treatment, because in terms of treatment, it's hard for physicians to go out and treat someone when there's not sufficient amounts of evidence for it. So that's why I have my thing. It shows or my kind of project. It shows the past and how it's such a big issue, and so my information hopefully will help people fund certain labs or help scientists or labs that need scientists kind of increase research on this certain topic. And then from here we have kind of like my my flow chart, I guess you could say, with all the questions and how they connect. And yeah, I wanted to go more into detail, but there was a time constriction, so hopefully it was good enough. But yeah, that's my project too.